Here's sample test 4, problem number 1. A current of 3 amps runs through a wire path as shown. The radius of the quarter circular arc is r equal to 2 centimeters. Determine the magnitude and direction of the magnetic field at point P. To deal with this kind of problem, with this kind of configuration, we want to break this up into separate segments that we can deal with. So we have a semi-infinitely long segment here, segment number 1, a curved segment here 2, and another semi-infinitely long segment 3 here. We'll look at these separately. We can see that point P is off the end of segment number 1. If you're off the end of a line segment of current, there will be no magnetic field produced at that point. So for segment number 1, we have B1 is equal to 0 because we're off the end of that segment. Sounds good? If we look at segment number 2, we have a curved segment, and for a curved segment the magnetic field is equal to mu naught I over 4 pi r times theta. In this case, mu naught is 4 pi times 10 to the minus 7. The current is 3 amps. R is 2 centimeters, which would be 2 times 10 to the minus 2. And then theta is going to be this angle that's being subtended by the arc as it's going this way. And that's just going to be 9 degrees, but we want it in radians, so that's going to be pi divided by 2. Alright, so the 4 pi's cancel out, and we have, well, let's figure it out. 2.356 times 10 to the minus 5 Tesla. Is it into or out of the page? Well, if you were to point the thumb of your right hand in the direction of this current, your fingers would curl out of the page to the right of this curved segment and into the page to the left as it's curling around this wire with your right hand. So where P is concerned, this magnetic field is coming out of the page. So we'll designate that as out of the page. Alright, sounds good. So that is 2. Now we want to look at 3. 3, this segment right here. It's kind of offset from point P by distance r, and we're going to go all the way this way as this current is going here. Our first angle then is going to be this angle right here, so that'll be theta 1, and our second angle will be this angle right here from the current direction, and the vector pointing back to the point is what we're looking at, and that's going to be theta 2. So as we go semi-infinitely long in that direction, we have that theta 1 is 9 degrees, or pi over 2, and theta 2 is 180 degrees, or just pi. Sounds good. So our magnetic field 3 is going to be mu naught I over 4 pi r, or r is our offset here, times the cosine of theta 1 minus the cosine of theta 2 for a line segment like this. So this would be equal to 4 pi times 10 to the minus 7 for mu naught times 3 amps over 4 pi. R just happens to be the same offset as the radius of that curvature, so that is 2 centimeters, or 2 times 10 to the minus 2. And then we have the cosine of 9 degrees minus the cosine of 180 degrees. Cosine of 9 degrees is 0. Cosine of 180 degrees is going to be negative 1. So this is going to be, and the 4 pi's cancel out. So we have 3 divided by 2 is 1.5 times 10 to the minus 5. 10 to the minus 7 divided by 10 to the minus 2 is 10 to the minus 5. Then we'll have 0 minus a negative 1, which would be 1. So this is going to be 1.5 times 10 to the minus 5 Tesla. And the question is, now, into or out of the page? If you were to point your right hand, thumb, in the direction of this current going to the left, then everything above this line of current is going to be going into the page. And everything to the bottom of this line of current is going to be coming out of the page towards you. So where P is concerned, it is going into the page. So this is into the page. So we have one magnetic field that's 0. We have one magnetic field that's coming out of the page, the other one that's going into the page. The bigger one's going to subtract from the little one. So our net magnetic field at point P is going to be equal to B2 minus B3. And that is going to be 2.356 minus 1.5, all this, times 10 to the minus 5, which is going to be equal to 0.856 times 10 to the minus 5, or we could say 8.56 times 10 to the minus 6 Tesla. And since B2 is bigger than B3, we're going to end up going in that direction, which will be out of the page. So that is our magnetic field at point P, 8.56 microtesla out of the page towards you.